Hello friends, welcome to Dr. Acharya Academy. Today we'll discuss about the chemistry class 11 from the syllabus CBSE. Today's topic is uncertainty in measurement. This is very critical topic to understand the certainty of the measurement. Today's class ID is 005. During the study of the chemistry, one has to deal with the experimental data and as well as the theoretical calculation. We know that during the chemistry quantitative understanding, we'll get the experimental data and out of we have to do calculation, theoretical calculation. There are meaningful ways to handle the numbers conveniently and present the data realistically with certainty to the extent possible. Chemistry is the study of the atoms and molecules which has the extremely low masses and extremely large numbers of the molecules and atoms. Examples of extremely large numbers is 2 grams of hydrogen gas contains this many numbers of molecules. That means in this number right side, if you see that 20 numbers of 0 is there. So that many large number of molecules present in the 2 grams of hydrogen. For the extremely small number, weight of the one atom of hydrogen is so much low numbers, because if you see that, then this value 166 and in the left side so many 0 is there. So it is a real challenge to do simple mathematical operations of addition, subtraction, multiplication or division with such numbers. So how to do that we'll see. This problem is solved by using a scientific notation for such numbers, that is exponential notation, in which any number can be represented in the form of capital N multiplied by 10 to the power small n. So with this notation, we can represent this value, where the n is the exponent having both positive and negative values. N, capital N, is a number called the digit term, which varies between 1.000 ... and 9.999 ... So example, we can write the 232.508 as 2.32508 multiplied by 10 to the power 2 in the scientific notation. Similarly, 0.00016 can be written as the 1.6 multiplied by 10 to the minus 4. So when left side is 0 is there after decimal, then we have to put the minus symbol of the small n value, exponent value. So for multiplication and division, we'll see, if you multiply these two numbers, 5.6 multiplied by 10 to the 5 and again multiplied by 6.9 multiplied by 10 to the power 8, then you see that these two you have to multiply and again you have to multiply with 10 to the power this 5 and 8 you have to add. Here you can see that 5.6 multiplied by 6.9 whole multiplied by 10 to the power 5 plus 8, and ultimately 5 plus 8 it will come to the 13. And if you multiply this first one 5.6 multiplied by 6.9, then it will come 38.64, and then again the second part multiplied by 10 to the 13. So if you simplify, then it will be 3.864. And similarly, if you go for the another set of numbers to multiply, which has 10 to the power that small n, what is there, it is a negative value. In that case, in similar way, you have to do that. First two portion you have to multiply. Here 9.8 multiply 10 to the minus 2, and again multiply 2.5 multiply 10 to the minus 6. Then this first two part, that is 9.8 will multiply by 2.5, and the second part 10 to the minus 2 and 10 to the minus 6. Then this you have to add, that means 10 to the power minus 2 minus 6, and ultimately the value will come in the same way, 2.450 multiplied by 10 to the minus 7. In the same way, if you go for division, that means 2.7 multiplied by 10 to the minus 3 divided by 5.5 multiplied by 10 to the 4. So first two part, that means 2.7 divided by 5.5, this is the first part, and second part is the 10 to the power minus 3, and this 4 if you go up, then automatically symbol will be changed, so from plus to minus, and then this part minus 3 minus 4, it will come minus 7, and first part you have to go for divide, 2.7 divided by 5.5, and it will come 0.4909, and if you simplify it, that means this decimal point, if you put the right side, then 7 minus 7 will come to the minus 8. Now addition and subtraction for two operations. First, the numbers are written in such a way that they have the same exponent. Because for the multiplication and division, that is the difference. No need to change the 10 to the power n values in the same exponent. But for the addition and subtraction, we have to do that. And if we go for the example, you see that if you subtract the 2.5 multiplied by 10 to the minus 2 minus 4.8 multiplied by 10 to the minus 3. So what we have to do, that we have to convert to the same exponent, that means minus 2 and minus 3. It will come either minus 2 both or minus 3 for both. So we'll put it the 10 to the minus 2 for the both value. So first case, as it is 2.5 multiplied 10 to the power minus 2, but in second case, this decimal point you have to take the left side to get the 10 to the power minus 3 plus 1. That means it will come 10 to the minus 2, and then first part, the decimal value is come to decimal point comes to the left, so 0.48. So now you can see that these two exponent value is the same value. So you can take common from this, and then whatever the first value is there, you can subtract. If for addition, then you have to add this. Here it will come the plus symbol. So first part, if you go for subtraction, then ultimately value will come 2.02 multiplied by 10 to the power minus 2. So in this way, we can simplify the both multiplication and division as well as addition and subtraction in a very simple way. Now, every experimental measurements have some amount of uncertainty. The term we are using now, uncertainty, associated with it. But because of the limitation of the measuring instrument, we'll give an example, and the skill of the person making the measurement. So two factors will include for the uncertainty in experimental measurements. First is the limitation of the measuring instrument, and second, the skill of the person making the measurement. For example, mass on an object is obtained using a platform balance. Balance is two types. One is the platform balance and another is the analytical balance. So if we measure an object by the platform balance, then this value has come out 9.4 gram. But same object, if you measure with the analytical balance, then the mass obtained 9.4213 gram. So definitely here some difference you can find, that in the platform balance you get only the 9.4 gram, but for the more precise balance, analytical balance, you will get the 213 gram. So here after decimal, you can see the only one digit, but in the last case for the analytical balance, after decimal point, you'll get the 4 digit. So definitely there is some difference. So the mass obtained by an analytical balance is slightly higher. That means this value is slightly higher than this, because this is 9.4, and for the analytical balance, for the measurement 9.4, after that 213 added. Therefore, in the first case, that means in the platform balance, this 4, this digit is placed after the decimal. This is the decimal point, you know. After decimal, one digit 4 is added, and this one is the uncertain. So therefore, the digit 4 is placed after decimal in the measurement. Here you can see this is the 4, and after decimal point it is at this is the decimal point, and this 4 is now uncertain. The uncertainty in the experimental or the calculated values is indicated by mentioning the number of the significant figures. Now what is significant figures? Significant figures are meaningful digits which are known with certainty plus 1, which is estimated or uncertain. The uncertainty is indicated by writing the certain digits and the last uncertain digits. We'll give one example now, so then it will be very much clear to you. Suppose one measurement is the 11.2 ml. For measuring the volume of one liquid, it is the 11.2 ml. So as I told that from the left side, this 1, these 2 digits, these are the certain. And last one from the right side, this is the uncertain. Why? Because during the measurement, it may be 11.2 or 11.1 or 11.3. That means these 2 is possible, maybe 1, maybe 3. As I told that any measurement depends on the 2 factors. One is from the uncertainty will come from the instrument itself, and another was from the human factor. That means who is measuring this experimental value. So that's why this 2 is uncertain. So here the significant figure, if you write, then this 2 digit, that means significant figure, figure number, these 2 digit, that means 2 plus uncertain figure 1, that means ultimately it is the 3. Now, there are certain rules for determining the number of the significant figures that we will explain. 5 points is there. Number 1, all non-zero digits are significant. For example, 3 to 6 centimeter, this 3 to 6, this value, what is this? The 3. So, these 3 are the significant figure. It doesn't have any 0, as you understood that. Maybe in between, if 0 is there also, suppose in place of 2, 0 is there, that also will be accountable as a significant figure. But in the 0.42 ml, there the extreme left side 0 is there. This will not be accounted as a significant figure. So in this case, significant figure is only 2. So whatever the left side 0 is there, it will not be accountable for counting the significant figures. Number 2, zeros preceding to first non-zero digit is not significant. Such 0 indicates the position of the decimal points. Example, this is the example 0.05. So 0, this 0 preceding from the non-zero digit, this is 5. So this also will not be accountable because this 0 only to indicate the position of this decimal point. So this 0 and this 0 will not be accountable for counting the significant figure. So what will have? It has only one significant figure. And similarly 0.0027, it has only 27, these 2 digit, that means 2 significant figures, because from the left side these 3 zeros will not be accountable for the significant figures. So zeros preceding to first non-zero digit are not significant. 0 between 2 non-zero digits are significant. In first case, here I already told that, for example, 3.007. So these 2 0 is the in between 2 non-zero digit. Non-zero digit here is 3 and 7, and these 2 zeros are in between these. So it will be counted as a significant figure. So 3.007, it has the 1, 2, 3, 4, that means 4 significant figures. I think this much you understood clearly. Now point number 4, zeros at the end or right of a number are significant provided they are on the right side of the decimal point. Example, 0.400. So these 2 0 is the extreme right side after decimal point. This 0 will not be accountable as you told, rule number 2. So it has how many significant it has? Yes, 3. This 4, this 0 and this 0. So 1, 2, 3. So in this case, it has 3 significant figures. That means 0.400 has 3 significant figures. But one thing we have to remember, quick way to remember, that the terminal zeros are not significant if there is no decimal point. That means if decimal point is not there, then the terminal zeros, that means either left side or right side, this will not be counted as the significant figure. For example, 200 has only one significant figure because these 2 zeros are the terminal, right side terminal. But 200 dot, here I put the color dot, its meaning is different. So if dot is there, then it has the 3 significant figures. That means a dot before that 00 is there, and extreme left side 2, this is the non-zero digit. So it has 3 significant figures. So why I put dot? you will see now that 200 point dot, this is from the above all rules. If you follow, then you will find that it has the 4 significant figures. That means this 020 is the before the decimal point, and after decimal point 10 is there. So all 3 zeros will be accountable as significant figures. So here it has 200.0 has 4 significant figure, 1, 2, 3, 4. We can express the number 200. Why 200 has only one significant figure? You can see this because 200 can be represented as 2 multiplied by 10 to the power 2. So these 2 will be accountable as one significant figure. 10 to the power 0 multiplied by 10 to the power 2, it has the 2 significant figure, because in the first case you see 2.0. So 0 after decimal point right side it will be accountable, and 2 non-zero it will be already it will be already accountable. So in this case it has the 1, 2, that means 2 significant figures. And similarly, if you count for the 2.00 multiplied by 10 to the power 2, then here has 2.00 as the 3 significant figures. That means this 10 to the power n, that means 10 to the power 2 or 10 to the power 3, it doesn't have any impact in the counting of the significant figure. Now number 5. Counting the number of objects. When we count the number of objects, that means 3 balls, 30 eggs, etc. So it will have the infinite number of significant figures, as these are exact number and can be represented by writing infinite number of zeros after placing a decimal point. That means 3, you can write 3 is equal to 3 point, so many numbers 0 you can add, and for 30 also, after 30 if you put the decimal point, so many 0 you can put. So these all have the infinite significant figures for counting the number of objects. In this case 3 balls or 30 eggs, whatever you count. In numbers written in scientific notation, all digits are significant. As for example, 6.01 multiplied by 10 to the power 2 has 3 significant figures. Already we discussed about this. And 4.266 multiplied by 10 to the minus 3, it has 4 significant figures.